Tonight, we want to look at the size of inverter you need in your home. You know that inverter, we have different sizes. We have 0.8 kVA, we have 1 kVA, we have 1.5 kVA, we have 2.5 kVA, we have 2 kVA, we have 3 kVA, 3.5 kVA, we have 5 kVA, we have 7.5 kVA, we have 10 kVA, we have 15 kVA, we have 17.5 kVA, and 20 kVA, and so on. We have a lot of sizes of inverter. But tonight we want to look at important thing that tomorrow you will not ask somebody which size of inverter do I need in my home. The first thing, and that is why I put it, know the size of inverter you need in your home. Know the size of inverter you need in your home. The first thing to do is to figure out how much energy you use. Those particular items that you needed the power for, you figure them out. Then you will need to add up the energy you use from all the devices. Now, there is a number plate that is always in electronics. For example, you are using, you want to calculate for television, or you want to calculate for fan, any of the electronics appliances you have, you add them. The number plate, it is written there in watts. You add them, add all the watts together. As we move forward, you look at it and you will enjoy it. From today, you will know the size of inverter you need in your home or office. You will need to add up the energy you use from all the devices you have, like lighting points, the appliances, and gadgets. Lighting points, the number of the lighting point, the appliances, and the gadget, the television, the radio, the fridge, the AC, immediately or later. That is the one you are going to use on it now, or the one you are going to add later. And that is where we put tolerance. So when you use the stored power in the battery, if it's for your home, you can usually find this information on your electricity bill. Or if your electricity bill is not reliable, then you can now find it or on the meter, the bill on the meter, most especially the prepaid meter used today is there. But if you cannot, just total the numbers of the power you use. Those wattage are the number plates of every electronics. And that is why, so for example now, we want to give a little design for small size of inverter tonight, so that we can use it to get the big one. The table below shows how much energy some common home device use. In this example, all the devices together need what? 900 watts of energy. We start with fan. Number one, example. We are looking at it tonight. Number one is fan. Ceiling fan, usually 80 to 100 watts. Now we are taking 80 watts and 4 pieces. 80 watts. Fan. Then these are the items. These items. Quantity. Then units, watts, then total watts. then total watts. Then you have the total watts. I am trying to tabulate it now. Now, fan has 80 watts. Fan, item 1, fan. The quantity is 4. And it has what? 80 watts per 1. That is 320 watts. Do you see how to calculate? We have calculated for the fan now. The LED light. The LED light is 15 watts and we have 4 pieces. LED light number 2 is LED light. LED light. We have 4 pieces and each one is 15 watts. Therefore, we have 60 watts. Do you see how to get this information? Then we have LCD television. It's 120 watts and we have 2 pieces. 120 watts. That is LCD TV. We have 2 pieces and have 120 watts. That is 240 watts. 240 watts. Do you see how we are going? That is 240 watts. All right, now then laptop. The next thing is what? Laptop. The number 4 is laptop. We have laptop, and laptop usually is 100 to 110 watts, and we have it 100. We have it 1, and it's 110 watts, and we have 110 watts. We have it 110 watts, and we have it only 1. Then the laser printer. Printer usually is 60 watts, and we have it 2 pieces. The printer, we have now printer. Printer, we have it 2, and it's 60 watts. And with this 60 watts, we have 120 watts. Then the last thing is the phone charger. It's 25 watts, and we have 2 phone charger. That is the last one. Phone charger. Phone charger. We have it 2, and it's what? How many watts? Is 25 watts. And this 25 watts, that is to say the total is what? 50 watts. And as we tabulate it like this, then under the space of the board is not enough. So we will clean from up while we calculate it down, so that we can have the details as we move forward. Now we clean from this particular point. Right. So after you have seen that, now the total of, as we calculate, add everything together here, we have the total of 900 watts as the total wattage. The total wattage of the appliance is now equals to 900 watts. As you have this 900 watts, now you have gotten the total wattage is now 900 watts. Now, another thing, important thing you need to consider is that after you have the total is the power factor. And mind you that the power factor of most of the electronics, when you are talking about the electronics, the power factor is usually less than 1. You can choose 0.9, you can choose 0.8. The higher the power factor is better, but not up to 1. So what we are looking at now is that we consider the power factor. Now, if you have the total as 1 and the power factor, we are using 0.8 as our power factor. When the power factor is 0.8, when the power factor is 0.8, now we have to calculate how we are going to arrive at the particular inverter, the size of inverter needed in our home. We have gotten the total load that we want the inverter to carry. We have gotten the total load we want the inverter to carry. Now, the total wattage, when we talk of, we have gotten the total load. So, the power that we needed, the rating of the inverter that we needed is the total wattage. Total wattage, that is the 900 watts. Total wattage all over the power factor. Total wattage divided by the power factor. Total wattage divided by the power factor. Our power factor is 0.8. Total wattage is 900. So the size of the inverter is equals to total wattage over what? The power factor. Total wattage over the power factor. And mind you that we have the total wattage to be what? Equals to what? 900. Then the power factor is all over what? 0.8 as we use. So we have now gotten that, okay, the required VA. Wattage, we are talking of wattage. Wattage is equals to what? VA. Watts is equals to voltage times current. Voltage times current. That is equals to what? VA. Now, at this point, you have to divide this 900, which is the total wattage, by the power factor. And when you divide it like that, you have, when you divide it like that, you have 1,125 watts. Now, when you divide it, you have 1,125 watts. Mind you that this is the same thing as is equals to 1.125 kVA. Now, we have arrived at 1.125 kVA size of the inverter. And that is to say that the inverter will be inappropriate. And the inverter, mind you that the inverter will be inappropriate if you do not consider the surge power. and the probability of adding a few small appliances to the system later. It's very, very important, because anything you are doing, you need to have that tolerance that, okay, if there is a power surge and the arms increase, what will happen to the inverter? Or tomorrow you decide to add more load to the system. For example, you add more bulb, or you add another television, or you add another fan. How will this going to look at this point? That is where we bring in the issue of the tolerance. Some people add 30% of the total load, but when I am designing, I add 50% of the total load. And as such, when you have that 50% of the total load, you have more tolerance so that it can accommodate more later without having issue. And that is why when you add from here now, you realize that the 50%, that is the 50 over 100 of 900 watts. And at this point, you have 0 cancel 0. Then you have 5 here, this one becomes 1. That means you have what? This one becomes 2. You have 1 over 2 times what? 900. Now, as we got this one, when this one goes, this one will be equal to what? 450 watts. When you add the 50% to the total load, you have the 50% is 450. Now, that is to say that as you are adding to the total load is 900 plus 450. The answer is given to you. What is the answer is given to you? It's given to you 1,350. 1,300 and what? 50. 1,300 and what? 50. It will give you 1,350. 1,350. Now, in this 1,350, you are now the inverter that suppose that will be able to carry that load successfully without an issue or suitable for that your home with those appliances. You are now looking at when one thing with it is that you don't go back. You always move forward. Then you add the tolerance now, making it to be what? 1.5 kVA. 1.5 kVA. That is 1.5 kVA solar inverter that you will use to take care of these appliances. Do you need an inverter solar and inverter system in your home or in the office? You are free to contact us for a professional advice or for job, because number one, we do what we design. As I've just designed this one now, we design, we supply, we install, and we maintain. Just feel free, contact us, or you follow us on our social media. You get more light into it as we move forward to discuss some sensitive issues that bothers our client, that bothers the client, so that you can key in and have a good experience of solar inverter in your home. Thank you.